Start recording. I think I sent you guys out another review, right? I sent you two review. I think the first one on the like Thursday or Wednesday, and then the other one is on Friday. I would really highly recommend you to do the second one, because that one is more very geared towards your test one compared to the first one. So I really highly recommend you to do the first one. And if we have some time today, so we probably will do the little bit of a review today. So just to remind you guys, so those who forget that we have a test coming out. The first test is this coming Wednesday, the 5th, September 15th. It will consist of 2627, 31 to 34, 41, and 42. It is in CLA 116, and it starts from 2 o'clock and it ends at 3:30. So this is your test time here. So make sure you come during this time. I do have a review sections 30 minutes before this time. So at 1:30 to 2 o'clock, I do have a review. I will go to CLA 116 if there's no one in the class. If there's someone in the class, then I might need to move somewhere else. But if at 30 minutes before the test here, so if there's no one in the classroom, CLA 116, I will do a 30 minutes review, and we will be concentrate on this review that I sent it to you on the second day or last week somewhere. So this is the one that I really concentrate on. So your test the test one looks very similar to this, except I changed the numbers a little bit. You still have, the A, B. If I'm talking about A, B, C, D, yep, you will still have exactly the same A, B, C, D, E parts. So if I have time, we definitely go over some of these questions together today. Otherwise, come for Wednesday at 1:30 to 2 o'clock, review at CLA 116, and then test is 2 to 3:30. No graphing calculators. You can only use a scientific calculators. Does anyone have any questions with your first test?
Can we bring notes that we done or no?
No, there's no notes. Your task is all going to be closed book, closed notes.
Okay.
So again, really concentrate on this. That's why I didn't post any key or answers to this review test one here. It's because I really do want you guys to, try to do this, because if I just give you key, you just, where can you get help? You can get help from the Math Resource Center. Kelvin, right? So you get, how often you met with Matt Foss?
Too many times.
That's good. That is really good. So don't be shy, because that's where he is, and Matt keep on sending me emails. I was like, good, that's what. So he this semester he works a little bit with Math Center. I highly recommend, if I'm not around to tutor you or help you, I highly recommend you to go to Matt Foss or whoever who works in the Math Center to get help, especially these kind of questions that you have here. So there will be a one-word problem in your test, which is number 3. And I can tell you that your test one is exactly the same pattern. Means the first question is doing composition functions. The second question is doing inverse function. And then this question is doing that. So it's exactly the same, but again, it's different numbers. That's what I change. So I really strongly suggest you guys to work this one out, especially get help, okay? Anyone have any questions with your homework? So there are 3 homeworks. So usually the homework is due on Wednesday, but this 3 homework is due tomorrow by midnight. The reason why is because these 3 sections will be included on your test on Wednesday. So if I do it on Wednesday, then you guys will do not do this homework, and then you probably will fail my test because you didn't do all these 3 questions, these 3 chapters, not 3 questions. So make sure you guys, this is due on Tuesday. And also tomorrow, you guys have no class. I know we don't meet on Tuesday, but if you do have class on Tuesday with some other instructor, you don't meet on Tuesday. So I would recommend you guys to go get help, spend some time on this. So anyone have any homework questions for 3, 4, and 4.1 for me? Anyone? You guys are really asking me questions. If you do, let me know, because we need to go to 4.2. So again, remind you guys, 4.1, this how to find your asymptote, so horizontal and vertical asymptote is very, very important. So make sure you know how to do this. And also we talk about the behavior of f, means is it goes to infinity or negative infinity. That is very, very important. So we're going to talk about one questions that is very special, which is number 6. Okay, so usually in the test, I will give you a rational functions like this. I ask you to find the asymptotes and your all those goodies. But this time we do it the opposite. So let's take a look at question 6. This question, they want us to give me the rational functions where I provide you the asymptotes and no horizontal asymptote in this case. So you will get this kind of questions in my test. So how do we do this kind of questions that you see here is, please pay attention, very important as it is in the test. So if the question provide you vertical asymptote, please write that in a factor form. Factor means x minus or x plus a number. And usually this, you put it in your denominator, okay? If a question provide you zeros or x-intercept, they are the same thing. So make sure you also write this in a factor form, but you put this in the numerator, okay, the top one. And if there is a whole exists, that means something is canceled out. You also need to write this in a factor form, and you put it in both the denominator and numerator. And then you figure out your horizontal asymptote or your Slane asymptote. You will learn the Slane asymptote today. Later on. So this one you have we will figure this one out at the end. Okay. So so let's take a look at this example here. So for question number 6, they ask you for give me the functions that the vertical asymptote is this 2. So the first thing is write this in a factor form. So can someone tell me what is a factor form for x equals 2 and x equals to 1?
X plus 2, x minus 1.
So this will be your factor form, and we're gonna chuck this in your denominator because it's a vertical asymptote. So and don't forget this has a function. So the f of x equals to something on the top over by the bottom is x plus 2 and x minus 1. So this will be chucked in your denominator. So we're gonna figure out what is on the top. So what we need to do in this case is we don't have zeros, we don't have a whole in this case. So we tells us no horizontal asymptote. So the question gave us no horizontal. So can you tell me by looking at this chart here, what makes it has no horizontal asymptote? Is that A, B, or C?
C.
C. That's where I say no horizontal asymptote means n is greater than m. That means the power on the top is greater than the power on the bottom. So in order for us as no horizontal asymptote, your n has to be greater than m, means the top power has to. Now, if you void this fellow, what power do we have here?
2.
2. So that means your m in this case is 2. So in order for us to figure out what is on the top, then this number has to be more than 2. So in this case, that means that since m is equals to 2, when you void this one out, so that means your n in this case can be 3, 4, 5, anything that is above 2. So in order for us to make this as your having no horizontal asymptote, then this x has to be either power 3, or it can be power 4, or it can be power 5, as long as it is above 2. So this is one of your answer in this case. So your answer in this case is f of x equals to x cubed over by x minus plus 2x minus 2. This is one of the answer for this kind of questions. As you know, there's many other correct answers. In your test, you do not need to void this follow out because I'm not testing you how to void. I believe you know how to void it. So usually, so this kind of questions you will get in my test. You will see it in let's do one. Yeah, let's do one. Where was it at? Oops, sorry. Oh, it's right here. This is question number 7. See, this is the same thing asking you. I give you the vertical asymptote, I give you horizontal, I give you the x-intercept, I give you the whole. You need to give me the rational function in this case. So how do we do this question? First thing first, write your vertical asymptote into factor form. So write this in the factor form, anyone? This is the 4 points, exactly the same points in your test.
X parentheses x plus 3.
So it's x for the x equals to 0 and x plus 3 for the x minus 3. So this, you will chart this in your denominator. Okay. The x-intercept, which is just zeros, you need to also write this in your factor form. So how do you write this in the factor form? 2 will become what?
X minus 2 and x plus 1.
Yep. And we will chart this in the numerator to top. Whole, can you write this in a factor form? So x equals to 1 become x minus 1. So this will be in both numerator and denominator. And we leave the horizontal asymptote for a minute here. So what you do here is don't forget your f of x because it has the function f here. So the top one you have is x plus 2, x minus 2, sorry. X plus 1. This is the zeros or the x-intercept. And the x minus 1 of the whole, because we have the whole. And then the denominator, we have x plus 3 from the vertical asymptote, and the x minus 1 because of the whole. So that means this 2 is on the bottom, this 2 is on the top, this 2 on both. So again, when you FOIL the top one, the power in this case will be 3 because you multiply x and x and x, the power 3. And the bottom one, if you FOIL this, you will also get 3 because you got 1, 1, 1. So all the x's will power 1. So then we come up with the horizontal asymptote, y equals to 1/3. So can someone tell me using the chart again, as you know this chart is important, which one should we pick if I say y equals to 1/3? A, B, or C?
B.
It will be B. That means the n and m is the same power. So the good news is, yes, if you look at this, your n and m is exactly the same power. But as you know that in order for this has to be the ratio. That means the 1 is going to be on top, the 3 is going to be on the bottom because it's 1/3. So so that means your top one has to be 1. So that means you have to slot in a 3 in here. So this will be one of your answer in this question 7 here. So it's x plus 2, x minus 2, x plus 1, x minus 1, the 3 because of the 1/3, and then x plus 3 and x minus 1. And again, do not FOIL as I've written down here. So leave your answer like this. So this is your answer here. You guys all right here? Questions? This is in your test. Doing your test too. The review here. Okay. Anyone? Now, we're going to continue with 4.2. So this is the one, if you look at the review test, this is the number 9. This is cost 11 points. Yes, that means in your test one, you only got 9 questions, but you know, some of them have 4, like A, B, C, D, E. So this is 4.2. So we're going to talk about this. This costs 11 points in your test. So make sure you pay attention. So we talk about Slane asymptote in this case. So this is only happens when n is greater than m by 1 degree. Okay. So in this class, you only do more than 1 degree. So if your numerator degree is exactly 1 more degree higher than the denominator, then we have what we call as a Slane or oblique asymptote. In order for you to find this Slane or oblique asymptote, you require to perform syntactic division. Okay. And once you guys know how to do syntactic division, so you always have a remainder. So the remainder is always be ignored. And your equation for this case will be y equals to mx plus b. Okay, so so your Slane asymptote is always y equals to mx plus b, where m and b in this case is your quotient. Remember when you perform syntactic division, you got the quotient and the remainder. So the quotient that you get, the first only two numbers, and then the remainder. The first number is your m, and then the next number is your b, your slope and your y-intercept. So that is your Slane asymptote. In this class, we only do exactly one more degree. So you get this, but when you go to calculus, then it can be more. It can be by 2 more degrees. So if you have by 2 more degrees, then you will have a Slane asymptote of y equals to ax squared plus bx plus c. So that means that your asymptote now, your Slane asymptote is not going to be a straight linear line. It's going to be a parabola, and so on. If they go up by difference of 3 degrees, then you will get a quartic formula, means it's power 3. Okay, so and then fourth and so on. So in this case, we don't do this in our test because it's a lot of work here. But in calculus, you will see this when you go up more than 1 degree, or 2, 3, 4, 5. But for this case, we only do 1, so that's why it's a straight line, easier to graph. So so let's do some Slane asymptote in this case. Let's talk about not here. Let's do your test step. Test has it. All right. So this is question 8A. You need to find your asymptotes in this case, all. So it's all means horizontal, vertical, horizontal, or slanes, one of those, asymptote for this case. So first thing first, every time when you find asymptotes, you need to factor and cancel the common factor. So can someone help me to factor this function here, number 8A? Anyone? Can we factor him? Can you factor t squared plus 1? T plus 5 cannot be factored, so we just leave it like that. Can we factor t squared plus 1? No, we cannot factor that. T squared minus 1 can be factored, but plus, no. Anything, if you have 2 terms, have a positive in between, plus 3, plus 4, whatever it is, you cannot factor this. So you cannot factor this for them. So we always have a vertical asymptote. So in order for us to find a vertical asymptote, you set your denominator equals to 0. So you just set this equals to 0. Can someone tell me what is your vertical asymptote in this case?
-5.
Don't give me -5 in your test. I will take points off.
X equals
In this case, t equals.
T.
Yeah, in the test, it's going to be x, but this is t, which is fine. Don't forget, this is very important. I will take points off if you don't give me x equals, in this case, or t equals. Next, you look at either you got horizontal or vertical. So you look at your power. So what is the power on top and what is the power on the bottom?
2 and 1.
2 and 1. So we know that 2 is, n in this case is greater than m. So if you look at the same chart that we just, as I told you, this chart is very important. So which one are we picking? A, B, or C?
C.
We're picking C in this case is because n is greater than m. We don't say no horizontal, so we're going to use, so in this case, no horizontal asymptote, but we have a Slane asymptote in this case. So you do need to find this Slane asymptote. And how do we find your Slane asymptote in this case? Is perform syntactic division. So as you know, syntactic division has to do this. And what number should we put in here is your vertical asymptote, -5. Okay, don't forget. So if you have, is a way syntactic is you use that. And then the top one that you see here is the number you put it on here. So the first one is 1 because that's your x squared or t squared. What is the next one after t squared? You perform syntactic division. Do we have a 0, yes, because we don't have a t term here, so make sure you put a 0 and 1. And as usual, you drop your 1, and then this times this is -5. And then you add this, become -5, and then this times this is 25, and then add this become 26. Now, as I want to point out to you here is when you perform this oblique asymptote or slate asymptote, you ignore the remainder. So in this case, that your remainder that you get here will be ignored. The quotient, this is the quotient, is the one that we have. So this is a slate asymptote. So can someone tell me what is a slate asymptote in this case? Y equals to x minus 5. So this is your slate asymptote, and this is your vertical asymptote. Questions? This is in your test. You don't have any questions for me? Question B. Question B is asking the same thing. So g of x in this case is x squared plus 3x over by 2x squared plus 5x minus 3. So again, the first thing you need to do here is factor and cancel. So go ahead and factor this rational expression out, rational function out. Factor them out. And if it doesn't know factoring, you lose 3 points on this one. Anyone know how to factor the top one? What can we factor up here?
So x times x plus 3.
Very good. That is correct. The bottom ones, so it'd be 2x times x. That will give me 2x squared. Oh, forgot the square here. And then the 3 usually is 1 and 3. And kind of, I can tell you that this will be a plus, this will be a minus because there's a cancellation. How do we know if this factor is correct? You just performing foiling. So 2x times x is 2x squared. 2x times 3 is 6x. And then -1 times x is -x, which is positive 5x, which is correct. So this factor is correct. What you need to do here is this below has to be canceled out. So this is where the whole came out. Okay, if you have so the remaining here is x over by 2x minus 1. This is what you left. X in this case cannot be -3 because of your cancellation, your what we call as a whole here. So by looking at this, can you tell me what is your vertical asymptote? Horizontal, let's see. You can use this shortcut, VAHASA.
Is it x equals 1/2?
Yep. So you set your denominator equals to 0 and you get x equals to 1/2. In order for us to figure out, you can only have the horizontal or you can have slate. You cannot have both. So what you need to do is look at your power. What power do we have on the top here?
1.
And the bottom one? Also 1. They're all same power. So if you remember the table again that I showed it to you up here, if they are the same power, I'll be picking A, B, or C. We are doing B. So in this case, it's y equals to the ratio. There's a horizontal asymptote. So that means that this fellow has no slate asymptote. You will have a horizontal asymptote of y equals to leading coefficient. What are the leading coefficients in the case, in this case?
1 and 2.
1 and 2, 1/2. So this is your answer in this case. You guys all right with this question 8? Save this. So again, as I told you, this is all in your test on Wednesday. So make sure you practice this. This is review test 1 question 8. Okay, so you will get a copy of it. So now we go to the main thing, which is graphing it. So in order for us to graph a rational functions, you have to go through this crazy 7 steps. Okay. The first thing is make sure you simplify f is possible. Simplify in this case means factor and cancel. The one that we just did early, like the previous example, you have to factor and cancel it. Once you figure out the factor and canceling, usually I will ask you to find the domain. And usually the domain for such thing is always all real numbers. X cannot be something, you know, what happened in the denominator. Okay. And then next you have to find your y-intercept. In order for us to find a y-intercept, you have to set all your x to become 0. So put your original function, set it to 0, you get solve and you will get yourself y-intercept. And don't forget, in order for you to write the y-intercept, it's not a y equals to 3 or something. So it has to be in a coordinates form, 0 something. Okay, so this is how you write your y-intercept in your homework in my test. Don't write y equals to 3, which is 0, 3. So it's in coordinates form. In order for us to find the x-intercept, 0 is the x-intercept, you have to set your numerator equals to 0. Okay, so the top one, you set the top one and nx, numerator equals to 0. And again, your answer in this case is gonna be coordinates 2. Don't give me x equals to 5 or something else. It's 5, 0. Okay, it can have multiples, so it's not just one. It can have a few more. So a few more, then you give me more. And then usually, if that is a whole axis, you have to tell me the coordinates of the whole in this case. The whole can only exist if you cancel your common factor, like the one that we did in chapter the question 8b. We cancel the x plus 3, so that will make a whole in that x plus 3 in this case. So if you have no cancellation, that means there will be no whole axis in this case. Okay. So this is how you find your x-intercept, your y-intercept, and the whole coordinates. Next, we figure out if your then you have to find your vertical asymptote. So in order for you to find the vertical asymptote, you have to set your denominator equals to 0. So vertical asymptote, set denominator equals to 0, x-intercept, set numerator equals to 0, y-intercept, set x equals to 0. And then after that, you have to figure out, do we have a horizontal or a slant asymptote by looking at the table. Remember the table I showed to you earlier on, the ABC. Okay, ABC. Okay. So make sure you know that, very important. You can either have this or this, means you cannot have both of this. Okay. So if you have a syntactic division, make sure if you have slant asymptote, make sure you use syntactic division to figure out the slant asymptote, and the answer is always y equals mx plus b. And I'm going to cut 6 off. So once you got that, I am cutting 6. I'm going to add this. This is 6. So I'm going to add 6 down here. I have no room here. 6. Does the HA or the SA, horizontal stable asymptote, cross the graph? Yes, give me the coordinates. So sometimes your slant asymptote or your horizontal, your graph can cross on this asymptote, horizontal slant. If you do, you need to give me where does it cross. It never cross on the vertical. Okay, it never cross on the vertical. And then the 7, you have to talk about the end behavior of the graph by the vertical asymptote. What do you mean by end behavior of the graph? Means that it's the nearby the vertical asymptote is a graph going infinity or negative infinity, means goes up or goes down. And then the last thing you need to do is to perform graphing. So this is the correct way to do it. So the one that I showed to you here is not the correct way. So this will be replacing. Okay, so you actually has a few, there's a lot of work. I didn't say it's easy, right? So this worth like 11, 12 points in your test. So it's a big, big part of it. So we're gonna go through this together. It's very, we're gonna spend a bit more time on it, and then we'll talk about number 5. So let's talk about number 6 here. Okay, so we're gonna apply same thing, all 8 steps into number 6. So let me copy it down here. Now there are videos for this. So some of you watch my videos on YouTube, how we perform all these 8 steps on question 6, 7, 8, 9. Good. If you have not, I would recommend you to watch it, and then we'll probably spend some time working on one of the review tests, number 9, which is the same. So we will talk about that. So so first thing first is factor it. So can you guys help me to factor question 6 here?
The denominator would be x minus 3, x plus 3.
Yep, that will be it. Can we cancel anything on common factors here?
No, there is no whole.
There's no whole. Yep. So no cancellation. That would be no whole in this case. Okay. Next, what we do here is we need to find your domain. So the first question in your usually in the task asks you for the domain. So don't forget to write all real numbers except what? X cannot be what? So set this equals to 0.
-3.
So plus minus 3. Yes, you can do this in my test, plus minus 3. So set that equals to 0 and solve for it. So that's how you figure out your domain. Anyone okay here so far? Because this is in your test worth 11 points. Next, you have to find your intercepts. So let's find your x-intercept first, and then after that, you find your y-intercept. And we already know there's no whole in this case because there's no cancellation. So in order for us to find your x-intercept, you set your numerator equals to 0. Numerator is the top one. So this is the top one. So you just set x equals to 0. So that's your answer because you do need to solve it. So that means your x-intercept in this case will be 0, 0. In order for us to find your y-intercept, you set all the x to become 0. So you set all this to become 0. So y in this case is 0 over by 0 squared minus 9. So again, I put all my x to become 0. So this will give me 0. Because 0 divided by anything is 0. So my y-intercept in this case will be 0, 0. And there's no whole. So this is how we do A, domain, B, the intercepts and the whole. And now we do C, is your asymptotes. So first thing first, we find your vertical asymptote. Remember how you find your vertical asymptotes?
So denominator equal to 0.
Yep, set your denominator equals to 0. So again, very similar to your domain. So your x in this case is what? Plus minus 3. And don't forget, I need x equals to give me plus minus 3. And I'm going to box all this important stuff because this you need to put it on your graph. So I'm going to box all these intercepts and the asymptotes. Now look at your powers. What power do we have on top here?
1.
Bottom 2, right? 1 and 2 here. So now you need to refer back to, that's why I want to tell you that this, whatever that I showed to you earlier on, keep on referring to ABC. That is very important. So which one do we have here for this example? A, B, or C? Is n less, n equal, or n greater than n? A, right? So that means it has a horizontal asymptote at y equals to 0. So this is an A piece here. So it does have a horizontal asymptote at y equals to 0, which is your x-axis. Okay, so this is how we do your asymptotes. And Next, D. You guys following so far? D is asking is, does this HA cross the graph, sorry, the graph cross the horizontal? So is the graph crosses the HA? So how do we figure this out? No, if it does, you take the hx, the function x over x squared minus 9, and you set it equals to your HA, in this case 0. Okay, whatever your HA that you found in part C, if it's 1, 1. If it's 1/2, 1/2. If you got a slant asymptote, usually a slant asymptote is y equals to x minus 5, right? So then you have to set this into x minus 5. So whatever you have in your horizontal or slant asymptote that you do part C here, it will be replaced by take this equation equals to 0 and solve for x. So what do? Is I multiply this whole thing, x squared minus 9, to that side, because I don't like fraction. And we know that 0 multiplied by anything is 0. So in this case, we can solve for x. So in this case, do this graph cross on the horizontal asymptote? Since we solve, the answer is yes. And it crosses at 0, 0. How do I know 0, 0? Because my x is 0 and my y is 0. So that's how you figure out where is it. You solve for x, let's say x is 5, then it will be 5, 0, because your HA is 0, your y is 0 in this case. So it depends on what you solve. In this case, is 0. So that is the step. That's A, B, C, D. That's the 4th step. And then we do the 5th step. I'm going to use gray. Now, 5th step is very, very tricky. It's because this is where we talk about your end behavior. So what is the meaning of end behavior? Means that means that when it close to the vertical end behavior of vertical asymptote, when it get close to the positive and negative 3, is that go up or go down on the left, on the right hand side? So what we're going to talk here is, let's concentrate on 3. So I'm going to draw the graph here so you guys will see what do I mean by that. Okay, so the graph, and we got a vertical asymptote. Don't forget, you need to draw this in my test, and you always use dashed line for vertical asymptote. So we got 3 and negative 3 on the vertical. So first thing we need to figure out is the one on the left. So negative 3 minus, so this side. You got to give me a number that is very close to this. So can someone give me a number that is very close to negative 3 on the left side?
Negative 3.01.
Negative 3.01. And what you need to do is plug this into this function that you have. I just want to figure out, are they negative or positive infinity? You do not need to really calculate what value is this. So when you plug this, you get a negative 3.01, which is negative. What is negative 3.01 plus 3? Is that a positive or negative number? If you put negative 3.01 on here, you will get negative. And what happens if you put negative 3.01 minus 3? That one is also negative, right? So how many negatives do you see in this equation, in this function here? You got 3. You guys remember, right? 2 negative is positive, 3 negative is negative, 4, all the even ones is positive, right? All. So since we got 3, so that means that this function will go to negative infinity. So what is telling us that at this point, it will goes down. That is the meaning of the end behavior. But don't forget, it comes with pairs. So that means you need to figure out what happens when it goes to negative 3 plus. Means now you're going to figure out the right side of it. That value is going to be negative 2.99999, because that is a number very close to here. So if you plug negative 2.999 into your x here, we still get negative on top, because negative 2.99. Negative 2.999 plus 3, you will get a positive. And negative 2.99 minus 3 will get a negative, because this is a negative 5.999. So what you got here is 2 negative, means that this fellow will go to positive infinity. So at this right-hand side, this fellow will go up. Are you guys with me so far? Difficult? Yes. A lot of work? Yes. Points? Lots of points. Now this is just for the -3. So now you're gonna do the same thing for the 3, the other vertical asymptote. So now we're gonna do the left side of the 3. So we're gonna use 2.99999 because that number is less than 3, just a little bit. So we plug this into this function. So this will be a plus because 2.99 is a positive. 2.99 plus 3, that is a positive. And 2.99 minus 3 is a negative. So this fellow will give us a negative infinity. So that means that on the left side, on the vertical asymptote, this will go down. And then the last thing we do is the right side. So on this side. So we will use 3.001 or 3.01. Okay, it doesn't matter because we just need to figure out are they negative or positive. So plug into your x, 3.01 is a positive. 3.01 plus 3 is also positive. And 3.01 minus 3 is also positive. So this means this goes to positive infinity. So what does that mean is at this point, this fellow goes up. You guys okay here with this part E? Questions? And F? Yep.
In part D, how do you know if it crosses the
You take the h of x, make it equals to your asymptote, the horizontal asymptote. And you figure out, you solve for x. If you're able to solve for x, like here, we can solve for x, then it is crosses. If you can't solve for x, you cannot solve for x here, then it does not cross.
Thank
you. I will give an example for this case. Okay, so far this is it crosses. So now we're gonna get all this information and plug it in here. So our x-intercept, our y-intercept, and the graph all crosses at 0, 0, which is right here. Redid your vertical asymptote, which is the 3 and -3. And now we do the horizontal asymptote, which is y equals to 0, which is the x-intercept, which is this pregnant line here. So when you guys got this, that means that your graph will be on top or the bottom on this side, top or bottom. So on the left, right side, your graph is going to be like a boomerang. So it can be going like this or going like this. And the right-hand side is also can be going like this or going like this. And how do we know which one to pick? You're looking at your end behavior. So if you look at the left side here, the end behavior says it's going down on this side. So that means that it is not going to be on top here. So you can erase this fellow because this is not your graph. So your graph will be going to be on this side, on the bottom part here. So this is your graph here. Let me so this graph will be over here. It's going to be like a boomerang. This one, because the end behavior telling us it's going positive infinity on the 3+, so it will be going down this way. So this is usually how we draw your left and the right graph. It's always a boomerang. Either top or bottom depends on your end behavior that you calculate in E. And then in the middle, if you do have a middle, your middle can be parabola open outward, parabola open downward. It can be a cube functions like this. And it all depends on your end behavior. And since this end behavior telling us up here and down there, so that means that this graph is going to be look something like this, like an opposite of cubic. So it's going to be look something like this. So this is your graph for question 6. In your test, this was 11 points. You guys all right here? It's difficult, right? This is the stuff that we will be doing. Let me save this. So you will, this is 4.2, page 1. Anyone have any questions for me with this? And anyone has asked you, do we have a shortcut? No, the only shortcut I can tell you is use your graphing calculators, but as you know that you are not to use, you cannot use one in the test. So forget about it. So we're gonna repeat again, but this time I'm gonna do it on your test. So this is a test question that we have. This is a test, the review, treat it like a test. So this is question 9 on your test. It's written down that your g of x in this case is given us by x squared minus x minus 6 over by x squared minus 16. The first thing, even I even read A, B, C, D, E, F, factor. So go ahead and help me to factor question 9. Then we do the A, B, C, D. One. What's the factor of x squared minus x minus 6 and x squared minus 6? This one is easy to factor. Yep, go ahead.
X minus 3, x plus 2, and the bottom would be x plus 4, x minus 4.
Yep. So I want to tell you that in the test, you will get very simple factor like this. So make sure you know how to factor. This is considered simple or easy factor. So I won't give you something tough. So because it does have a domino effect, means that if you got this wrong, everything you after that is wrong. So make sure you, that's why you brush up your factoring here. So now we do part A, the domain. So can someone tell me what is the domain for this question?
X equals -4, x equals +4.
Don't give me that, Calvin.
All
Real numbers. Yep. So don't do what Calvin did. You lose 0.2, you lose half a point. X equals to 4 plus minus 4 is all real numbers. X cannot be plus minus 4. So be careful. I like to take points off your test. So don't let me take points off your test. Can we cancel anything here?
No.
So that means there's no hole involved. Okay, we don't have any hole in this case. So next we have to find your intercepts, x and y, and then hole. We know there's no hole in this case. So let's find your x-intercept. Does anyone remember how you find your x-intercept?
Set it to 0.
So set your numerator equals to 0. So the top one. So can someone tell me what you get when you make this equal to 0? Three and
-2.
-2. Yep. So it's 3, 0 and -2, 0. Make sure you know how to write this in coordinates. Y-intercept. How do you find your y-intercept? You set all your x to become 0. Now you can set this all to become 0 and multiply them, but the easiest way is to set this to become 0. So what we have when you set that it becomes 0 is 0 squared minus 0 minus 6 over by 0 squared minus 16. So you set this becomes 0 because it's easy to do that way. This will become -6. This will become -16. So don't forget to reduce this. So this is actually 308 if you reduce this. So your y-intercept in this case is 038. So I'm going to box this one up and box the other one up. And we know there's no hole in this case. Okay, here so far. I'm not taking attendance yet. You guys are so antsy. Next, C. C is asking you to find asymptotes. So vertical, horizontal plane. So let's do the vertical asymptote first. So anyone remember how you find your vertical asymptotes?
Set the denominator equal to 0.
That is easy, right? It's very similar to your domain. So x in this, don't forgive me, give me x. X equals to what?
4 and -4.
Yep. Now look at your powers. So what power do we have on top and what power do we have on the bottom? The top one is power 2. The bottom one is also power 2, means same power. So if they are the same power, do we have horizontal or do we have slant?
Horizontal.
So we do have a horizontal asymptote, and we use the ratio of the leading coefficient. What's the leading coefficient we have? 1 and 1. So it's 1/1. In this case, it's 1. You guys all right here so far? And for this is part C. For part D, they ask you, does the graph crosses on the horizontal or the horizontal or the slant asymptote? If it does, what is the coordinates? So how do we do part D in this case is, so pay attention, you take the g of x, which is x squared minus x minus 6, over by x squared minus 16, and then make this all equals to, anyone know what it's equals to? Whatever you found in C on the horizontal asymptote, which is what?
1.
1. So whatever you found here, make it equal to that number. And solve for x. So I'm going to multiply this whole thing to that side because I want to get rid of the denominator. Distribute the 1, so you will get x squared minus x minus 6 equals to x squared minus 16. And what happened is that your x squared and x squared will cancel when you subtract x squared on both sides. And then solve for x, so we add 6 here. Move my 6 over there. So negative x in this case is negative 10. So x in this case is 10. So in this case, it does cross on the horizontal asymptote. What is the coordinate that it crosses? X is 10. And what is your y?
1.
1 from the horizontal asymptote. Okay, so that means that at 10, 1, the coordinates 10, 1, it will cross over there. Okay. E, if you look at E, is asking you for the behavior of G near the vertical asymptote, means that the minus and the plus that we talk about. So in this case, we got 4. So I'll do E and F because usually you will see more clearly. So we have 4 and negative 4 is your vertical asymptotes. So negative 4 and 4. And yeah, I will give you graph paper, so it'd be nicer. So let's do x approaching at negative 4 minus, means at this point, we'll do negative 4.01 and plug it into this friend of yours. And I want to figure out, are they negative or positive? So negative 4 minus 3, this will be negative. Negative 4 plus 2, this is also negative. Negative 4 minus 4 is negative 8, it's negative. Negative 4.00001 plus 4, is that positive or negative when you plug this in?
Negative.
Yep. And how many negatives do we have? 4. So this goes infinite positive. So at this fellow, it goes up. Okay. So now we do the next one. Negative 4 plus. So I want to tell you that every vertical asymptote, you're going to do it in pairs. So you got 2, you're going to do 4 times. If you got 1, you need to do 2 times. The number that is close to negative 4 on the right side is negative 3.99999. So negative 4, negative 3.9 minus 3, this is minus. Negative 3.99 plus 2, this is also minus. Negative 3.99 minus 4 is also minus. And negative 3.99999 plus 4, what you get?
Positive.
This is positive. So how many negatives do you see here? 3. So this goes to negative infinity. So at this point, this fellow goes down. You guys okay here? And then we do the 4. So we got 4 minus, which is this fellow. And that number we use is 3.99999. So 3.99 minus 3, this is plus. 3.99 plus 2 is plus also. 3.9999 minus 4. This will become negative. And then 3.99 plus 4, this is positive. So this only have one negative, so it's negative infinity. So this fellow will go down. And the last one we do is 4 plus. Why don't you guys do it and tell me, is this fellow go up or down? And I'll take attendance. I know some of you put something in attendance already. That's good. So whoever that did not give me your attendance, please type in present in the chat room. If you did, don't repeat. Yep. And tell me what you get. We're gonna use 4.01 or 4.00001 on the right side. Is this negative or positive infinity? When you plug into here.
Positive.
So this is a positive infinity, so it means this fellow will goes up. Class, make sure you know how to do this. Very important. All right, now we both got everything here. So now we just, combine all the goodies into this graph. So I'm putting green. So 3, 3, 0. 3, 0 is this. This is my x-intercept. Negative 2, 0 is this. This is also my x-intercept. I got 2 x-intercept. 3, 8. 3, 8 is less than 1. So this will be my y-intercept. 0, 3, 8. If you use a calculator, 3, 8 is 0.4 something. Some is, just again estimated. We got your vertical asymptote, which is 4 and negative, x equals to 4 and negative 4, and your horizontal asymptote, y equals to 1. So this is a dashed line at 1. And then you told me that it is crossover at 10, 1. 10, 1 is all the way here. That's 10. This is like 10, 1. So at this point, the graph will cross on the horizontal asymptote. So can someone tell me, by looking at this, on the left side, is the boomerang is going to be on the top, on the bottom?
Top.
Because of this fellow will tell us on the top. Yep, that is correct. In the mid, on the right side, let's do on the right side. Obviously, middle. Is that on the top or on the bottom?
Top.
Also top, because it goes to infinity, positive infinity. But what happens is that at the point 10, 1, it will cross right there. So it will cross over here. And in the middle, is that going to be a parabola open upward, parabola open downwards, or cubic? Which one you think is this, the middle one?
Parabola downward.
Because these two arrows telling us to go downwards. So you draw a parabola that goes, crossing those points. So this is your graph for number 9 in your test, in your review. You guys all right? Can you guys do this in my test? 11 points here. You guys all right?
Yeah.
Okay, so I'm gonna give you some. So far we did something that is we don't have any hole involved. Okay, so we'll see something that had a hole involved. Let's see where was that. Nope, that's what doesn't have hole. This question 7 is very similar to question 9 that we just did just now. I would recommend you guys to do it your own. Okay, refer to the one that we just did. Okay, so we're gonna do something with the hole. Yep, this was the whole question 8 here. So we're gonna talk about this fellow. So question 8. F of x equals to 5x plus 20 over by that fellow. First factor it. Go ahead and factor number f of number 8 here.
X plus 4.
So the top one, you can factor out 5. You get what? X plus 4, right? And the bottom one, what's the factor for the bottom one?
X plus 4, x minus 3.
And in this case, you find out that the x plus 4 is canceled. That's where the whole comes from. So this function is actually 5 over by x minus 3. And x in this case cannot equal to negative 4. That's the whole in this case. And where do I get this? It comes from the one that cancel. You solve it equals to 0. That's why you get negative 4. So this is your new function now for the rational function. So we still need to find your domain, same thing. Don't forget the all real numbers. So what is the domain in this case? X cannot be what?
-4 and +3.
Yep. So don't forget the one that the whole that you cancel cannot take form of that. Okay. And the 3 from the denominator. So don't forget the one that you cancel for the whole, it plays it had to be in a part of the domain in this case. So x-intercept. So in order for us to find x-intercept, you put your numerator equals to 0. And are we looking at the original question, or are we looking for are you looking at the new one? Which one should we look when you do x and y intercept?
The new one.
The new one. So the numerator in this case is just 5. Can you solve for x here? No, you cannot solve for x. So in this case, DNE. So don't forget, if you cannot solve for x, or x doesn't exist here, so you cannot solve for it. So that means that it does, when I say DNE, means that it does not cross on the x-intercept. Okay. For y-intercept, we set this equals to 0. So you set all this x equals to 0. So you will get 20 on the top, because 5 times 0 is 0. And -12 on the bottom, because those are zeros here. So you just set all these friends become 0, all the x. Reduce this by 4, you will get -5/3. You should know how to reduce. Do you know how to use your calculator to reduce a fraction? The ABC button. So make sure you use your ABC. But if you have your calculator with you, make sure you use your ABC button to reduce your fraction. I think I teach you guys on the first day of class, second day, something like that. So please refer to that. We got whole now since you cancel something. So how do you figure out the location of the coordinates of whole? Is you set x equals to -4. Where is this -4 comes from? It comes from what you cancel, the +4. So you just find is f -4 is. So you get 5 on top over by -4, -3. So I just need to set the x here to become -4. That's how you figure out the coordinates of the whole. In this case, is 5 over -7. So the coordinates of whole in this case is when x is -4, the y value is -5/7. So that's all. location. You guys all right? Tough. Now we look at talking about asymptotes. So your vertical asymptote, you set your denominator equals to 0. So x minus 3 equals to 0. That means x equals to 3. Again, we look at the new one. Now, this fellow, once you factor it, you don't need to even look at it anymore. Okay, we concentrate on this fellow. Okay. Yep, you here. You know what? I should just erase this fellow. Because if you put 0 in here, you still get -5. That's quicker. All right. Now look at your powers. Anyone can tell me what is the power on the top one?
Zero.
Yep. No x, 0. What's the power on the bottom one? 1, right? So if you remember, what do we do here? Anyone still remember? 0 is what? Less than, greater than, or equals to 1? A, B, or C? So it's A, right? 0 is n is less than m here, right? Not B, not C. So what do we have here? A vertical, a horizontal, or plane here?
Vertical.
We have a horizontal asymptote at y equals to 0. Okay, so this is how we figure out this. Now the next one is to figure out if this graph crosses at 0. So I take 5 over by x minus 3, make it equals to 0. Whatever we did here. And again, I multiply this by x minus 3 to the other side. So anything multiplied by 0, you get 0. And this question doesn't have x, cannot solve for x. So is this graph going to cross on the horizontal asymptote? The answer is no. So remember last time? Yes, we found it. The reason why we can solve for x for this case, because when you multiply, the x is no longer there. So you cannot solve for it. So that means that it never cross. You cannot cross on the horizontal asymptote. So this is how you perform this. And the last thing we do here is graphing it and then do your end behavior. The good news is how many vertical asymptote we have in this question? You only have 1. So you only need to do 2 times instead of 4 that we did last time. So you just need to figure out when x is approaching 3 minus and x is approaching 3 plus. And you're using this friend of yours. So it's easy to plug in. The 3 minus, we're going to use 2.99999. So 5 is still positive. 2.99999 minus 3, this is negative. So this gives me negative infinity. So this fellow will go down. And then we use 3.0001 here. So 5 is still positive here. But 3.0001 minus 3 is still positive. So this will give me a positive infinity. So again, so make sure you know that if you only got one vertical asymptote, you will need to do twice. The most I can give you the test is 2. I won't give you more than 2 because it give you a lot of work. So now here's the graph. So it doesn't cross on the x-intercept. The y-intercept, we cross at 0, 5 thirds. 0, 5 thirds is between -1 and -2, somewhere around here. It has a hole at -4, -5.7. So at -4, -5.7, you get a hole in the graph. Your vertical asymptote is x equals to 3. Your horizontal asymptote in this case is y equals to 0, which is your x-axis. and you cannot cross, there's no crossing. So that means that this one, you only got two boomerangs because you got one on the left side and one on the right side. There's no middle. So on the left side is a boomerang is on the top or on the bottom. Here
Left side's on the bottom.
on the bottom. So this fellow will go because of the negative infinity here. You go on here and it cross at this negative 5/3 that we found over here on the y-set. And then it will go by here, then you make a hole in here, and then you will go parallel, cannot cross that. So this is what happens when you get a hole situation. So it's a boomerang that's a hole in here. And then this one is going to be on the top on the right side because, and it will not cross on either your vertical or your horizontal asymptotes. So this is your graph for question 8. You guys all right? Tough or I can, this was a lot of points here. So far what we did here is everything has a horizontal asymptote. We never done anything with a slant asymptote. So now the last example we're going to talk about here is about the slant asymptote. So the last question that we have in your notes, question 9, is where we have a slant asymptote given to us. Okay. So question number 9 is kx equals to that. Go ahead and factor that follow up for me. Can we factor this fellow?
No.
No, yep, you cannot factor it. So what is your domain in this case? All real numbers, x cannot be what?
Zero.
Yep, cannot be 0. Since there is no factor, no cancellation, so there will be no hole in this case. So let's do the x-intercept. So you take the numerator, x squared plus 1 equals to 0, and solve for x. This is usually what you do for your x-intercept. Take the top equals to 0. When you move the 1 over, it becomes -1. And what happens when you take a square root of it?
Becomes I.
It becomes I. So in this case, since this fellow become I, so do we have any x-intercept in this case? No, we don't have it. The anymore. Y-intercept, you set all your x to become 0. So you will get 0 squared plus 1. I set this to become 0 and over 0. Do you know what happens when anything divided by 0?
Undefined.
Undefined. So in this case, do we have a y-intercept? D and E. So this graph has no x-intercept, has no y-intercept, and has no hole. Special case. Yeah, we call that. So part C is where you begin to find your vertical asymptote. So no matter what is, usually we have a vertical asymptote. So what is your vertical asymptote in this case? X equals to 0. Your denominator equals to 0. Now look at your numerator. This power is 2. And this power is what? 1, right? So what kind of asymptotes do we have? Horizontal or slant?
Slant.
We got slant asymptote. Now, in order for us to figure out your slant asymptote, you have to perform syntactic division. Remember last time we have this x plus 5 here, we put -5 here, right? But this fellow has no, just x. So what number should we put in here?
1.
No. 0. Okay. If it's x minus 1, then yes, you put 1 in there. Yeah, since there's no number, it's a 0. And what number should we put across here? You had to look this one. So 1 for the x squared. What else?
0,
0 and 1. Yeah, don't forget you need the 0 for the x term. So drop the 1. 0 times 1 is 0. Add this will become 0. As you know that we don't care about the remainder, so you do not need to perform it. So can someone tell me what is a Slater asymptote in this case? Y equals to this quotient,
x.
just x, mx plus b, and my m is 1, b is 0. So that is a Slater asymptote. Part D is figure out if this graph cross on a Slater asymptote. So you take the coordinate x, the function x squared plus 1 over x, make it equals to, what is the Slater asymptote you found in part C? X. So make it equals to x. So whatever you found here, use it here. If it's 3x, 3x, you know, whatever you have. Again, in order for get rid of this, I multiply this by x. So this is gone. So x squared plus 1 is equal to x squared. So you notice that the x squared is canceled. So you get 1 equals to 0. Can we solve for x in this case?
No.
So does this graph cross on that Slater asymptote? The answer is no. Okay. And we're gonna do a little bit of up and down. So 0, vertical asymptote is 0, which is right over here. This is 0. So we're gonna use 0 minus and 0 plus. What number is close to the 0 on the left side? Negative 0.1 or negative 0.0. Okay, this one is a little bit tricky. So when you plug negative 0.1 into top one, do you know what happens when you square him? That negative will become what?
Positive.
Positive. And then you add 1. You think this will be positive or negative number?
Positive.
Okay. And then when you put a negative 0.1, this will become a negative. So this is negative infinity. So this goes down on the left side. Right side, we go use 0.1 because on the right side. So when you put 0.1 squared plus 1, this fellow will be still positive. And we put 0.1 in the bottom, is still positive. So this telling me that this fellow will go to positive infinity. So this is your end behavior, which is good news. You got 2 because you got 1 vertical asymptote. So let's put all these friends together and oh, this is good news. No x-intercept, no y-intercept, no whole. We got the vertical asymptote at 0, but we have a Slater asymptote of y equals to x. How do you draw your y equals to x is because your y-intercept is 0 and your slope is 1. So you just go 1, 1 over 1, 1 over 1, like diagonals. So this is your y equals to x, your Slater asymptote. And you part D, it says it never crossed the slane because you say no, you're not crossing here. So that means that this fellow, if you look at the left side here, you say it's going down here. So actually it will go like this. And because you cannot cross on the Slater asymptote, so you go parallel with that Slater asymptote like that. Same thing happens to the right side. You say it's infinity, positive infinity. So, and then at this point, it cannot touch your Slater asymptote and you go parallel with it. So this is your graph for question 9 if you have a Slater asymptote. You guys all right?
How did you do the synthetic division for C?
You just, this is equals to 0. That's why I put this equals to 0 here. And then you use this for your numbers. So 1 and then 0. And you're talking about this one, right?
Yeah.
Yep. And because we're missing the x term, so that's you have to put a 0 in it.
And then what happens to the other one?
We don't care because when you do syntactic division, when you find the same asymptote, the remainder we don't care.
Okay.
So we just need to know the quotient. That's it. And then you drop the 1 and then multiply, the same thing that you did. Good. All right, I got one last question, which is number 5. So number 5 is the same thing as what we did early on, is where I want you to give me the function given us the vertical, now we got the slane and the zeros. So as I mentioned, the vertical, you put it in where? The top, the denominator, the top, the bottom, or both? You put this in the bottom, right? The denominator. Can you write this vertical asymptote in the factor form?
X minus 2.
X minus 2. I will wait for the slane asymptote. We do the zeros. Where should we put the zeros at?
Top and bottom.
No, that is a whole. So we talk about whole, then we put both. But 0, which is the same as your x-intercept. Don't forget, 0 is the same as your x-intercept. We put it in the numerator, top. And that is what? X plus 2, right? So what is going on in this question is you got the y, or should be f of x. F of x. The top one is x plus 2 and the bottom one is x minus 2. But because it has a slane asymptote, when you have a slane asymptote, we know that n is greater than m by 1. So what is my n here? If you look carefully, my n is 1. And this m is 1. So this cannot have a slane asymptote because it only have horizontal. So in order for us to have a slane asymptote, this fellow has to be x plus something. Because when you FOIL this, your power will be 2. Then you will get the slane asymptote 2 greater than 1. So my question is, how we figure this number out is doing some work here. So you're doing some work involved. So it's given us the slane asymptote in this case is y equals x plus 1. So what I did here is I will change this to become x plus 1, which is the same as your slane asymptote. And I make it equals to x plus 2, x plus, I put a here, which is, I define what a is, over by x minus 2. So our main goal here is to find a. So I just need to multiply this x minus 2 to this side. And I need to FOIL this fellow out. So foiling this fellow out will give us x squared minus x minus 2. Now you have to FOIL this fellow out. Foiling this fellow out, you will get x squared plus ax plus 2x plus 2a. So I'm foiling, this fellow out. And this middle term, I can combine it. So I will get x squared plus 2 plus ax plus 2a. So I just factor out the x here. So what we're gonna do is we need to try to solve for a. Now, as you know that when we do syntactic division, that just now, we don't care about the remainder. So that means that this, we don't care. The remainder is always the last number. The last number, you always cross it out. So in this case, you just need to take your x term and you kind of like make it equal. So this is -1 here on this side. And this side is 2 plus a. And you just need to solve for a. So a in this case is -3. So what you do is you just plug it back into this question mark here. And your answer is this below. So your answer is x plus 2, x minus 3 over by x minus 2. So this is how you do question number 5. And this is in your online homework. I won't ask this in your test. This is in your online homework, but in your online homework, you need to FOIL him out. So in your online homework, your final answer in this case, you have to FOIL a little bit. X squared minus x minus 6 over by x minus 2. So this is what you need. I won't ask you in your test, just in your online. So you just need to FOIL. But in my test, please do not FOIL it. You are wasting your time. I don't know why your homework wants you to FOIL it out, but in my test, leave it as x plus 2 and x minus 3. If you want to FOIL, you FOIL it, but I don't think so you have time to do it. So just leave it like that. So this is how we do question number 5. If they give you a slant asymptote instead of a horizontal asymptote that we did previously. Anyone have any questions for me before we end today's Zoom?
How did you get to 2 plus a equals -1?
So what happened is I'm comparing the x value on both sides. And the x value on this side is -1. And the x value on this side is 2 plus a. And then we just solve for a in this case. So usually this question is very special. This question is very special. So we have to do a little bit of comparing. And the reason why we don't compare the constant term is because when you do the synthetic division, we don't care about the remainder, and the remainder always comes from the constant term. So that's why we don't compare that. We only compare the x term.
You can just drop the x that's after the 2 plus a.
Yep. For this case, you're comparing x, so you just drop the x off. Yep. And again, this is a very difficult question, and I think only one question in your online will ask you this. All right, just to remind everyone again, your test is on Wednesday, this coming Wednesday from 2 to 3:30 and CIA 116. I will be in CIA 116 at 1:30 to 2 o'clock to review for your test. Since we already did questions 7, 8, and 9 for today's class, so we are not going to review 7, 8, 9. So we're going to review the first 6 questions. Okay, so make sure you I will go through these 6 questions with you guys. Some of the questions I have, because I got 30 minutes with you, I don't have time to go through it. So I like the question 4, you required to FOIL. So I just know you know how to FOIL it, so I'm not FOILing the whole thing up. So when I do something on on Wednesday at 1:30 to 2 o'clock, like synthetic division, I think you know how to do it. So I probably will do question 6A. Some of the questions I think you should be able to do it. So I would recommend the some of the questions I will definitely help you with that. So I will print this one out so you guys can play around with it. All right. Anyone have any questions for me before we end today's Zoom class here?
Can we bring like a blank sheet of paper to write?
Oh yeah, you can bring us. I will provide blank. I provide scratch papers. If you don't have a scientific calculators, I will provide it to you. Yep. You got everything. Yeah.
Thank you.
Yep. I'll see you guys on Wednesday. If you have no questions, if you have questions, please stay back. Yep. Yep.
You did.
Kamal, Kelvin, Andrew. Kelvin, I record. Kelvin, keep on signing up for Matt Foss tutoring. He's a good instructor.
Yeah, well, like the thing is like for him, like he has the graphing calculator. So like
Oh,
when
yeah.
I'm when I'm trying to figure out all the x-intercepts and like the points in general for like the graphs that we do on our homework,
Mhm.
he pulls it up a lot faster than I do because I only
yeah.
have the scientific calculator.
Yes, and you make sure you tell him that I can only use scientific calculator for my test.
Yeah.
If he check for answer, it's fine, but he can. Yeah,
Yeah.
you just need to let him know that I only allowed to use this.
Yeah,
in the test.
he started
know.
making this joke now that he was like, oh, well, I wouldn't use a calculator because I know you can't use a calculator.
Yes,
So I would just,
yes, I know what it means. So yeah, he just want to find. Usually he just need to use it to figure out the answer earlier ahead of time.
Okay. So
Yep.
on Wednesday, right? You said you'll be there at 1:30
1:30 to 2. If hopefully in the same classroom, CLA 116. If the classroom is taken, then I will tell you where to go. But I think it should be available at that time.
Okay. And also I have another question. So I actually have a class like that starts like literally right after this. Usually like I come to the campus and then I like rent out a room in the library or something. So like I'm always late to my next class. Like I'm going to be late to my next class because it's just now ending at 2:30.
Yeah, 3:30. What time is
Yeah.
the class starts on that?
3:30.
Oh,
So I was just gonna email you or say like, is it okay if I leave 5 minutes early?
yes, that one is fine. But for on Wednesday test, you might need to talk to that teacher
Okay.
that you have a test till 3:30. So
Okay.
you might be late just for those, for the test time.
Okay. Okay. Sounds
But
great.
for my regular class, you can always, leave at 3:20.
Okay.
And then after you just once I upload this into YouTube, you can watch the last 5-10 minutes.
Okay. Sounds great.
Mhm.
All right. Thank you.
See you on Wednesday.